Okay, here we're going to start with number 28 to 36, how we start multiplying it. Now the author starts with integers so you can get a feel about what you do as far as breaking it into bases and how to deal with that with the exponents when an index is involved. Okay, so let's break up 6. I tried to take care of some of the glare, so it's a little difficult for me to see in here a little bit. It's a little dark. Please let me know if this video comes a little clearer than the other ones with the light blocked off a little. All right, here we go. The 6 breaks into 2 by 3. And the 16, of course, breaks into 4 by 4. Now, as 4 by 4 is also 2 by 2, that's 2 squared times 2 squared, or 2 to the 4th. Now, as all of that is under the 1/3 power, that's a 1/3, or a cube root of them all. Now, when we multiply, we add exponents, so we'll do so to combine everything down, so we have individual bases, 2 to the 5th, 3 to the 1st, 3rd root. Now it becomes like the previous set of problems, where we're looking to get divisibility equal between the numerator and denominator here. So we're going to break this 2 to the 5th up so that 3 goes into it. So here we go. We would have the 3rd root of 2 to the 3rd times 2 to the 2nd times 3 to the 1st. Now, I know that 2 doesn't go into 3 and 1 doesn't go into 3 equally. However, 3 does, so at least we have something going on here. And now we write this in exponent form, where this is our denominator. So that would be 2 to the 3 over 3 times 2 to the 2 over 3 times 3 to the 1. And of course, this part just becomes 2 to the 1st. And then I'm going to put these two, oh, I forgot my 3. I'm going to put these two back as a radical, as the numerator is smaller than the denominator, discussed earlier videos. So that'll be 2 squared times 3 to the 1st, underneath, putting the 3 back outside. And of course, a final calculation will give you 2, the 3rd root of 4 times 3, or 2, the 3rd root of 12. All right, and we're going to repeat that process now, but we're just going to put some variables in as bases. Instead of 2's and 3's, you'll have an x and a y maybe. Same exact procedure. Please don't let the variables throw you off at all. All right, give me a second to clean the board. It's not like I have my smart board here. That would be great. What if I can uninstall it and bring it here? Did they give you permission? I can have that thing down in here in an hour. All right, number 30. We would have, which is the square root, 8x to the 5th. Now remember, this is even, so we're starting to watch the inside. Times 3x, square root of 3x. Square root of 3x. Okay, so as they both have the same index, I can simply multiply it. 8 times 3 times x to the 5th times x to the 1st, 24x to the 6th, square root. Okay, now here, this is the square root. So this, of course, is even. Therefore, if I plug the number in, I would still get a positive answer, and an absolute value would be required here at the end. So now we'll just consider the 24. We want to break that up into base form. Well, we had 8 by 3. I guess I should have left that and made that 2 to the 3rd times 3. So I'll replace this 2 to the 3rd times 3 times x to the 6th square root. Okay, I think you can tell now where we're going to go from the previous work. What I'm going to do is now write this 2 as the denominator for all of my bases. So 2 to the 3 over 2 times 3 to the 1 over 2 times x to the 6 over 2. Now, a minute here as I stop and I hesitated because I realized that I could have written this step as 2 to the 2nd times 2 to the 1st as I have been doing consistently before. I also mentioned as you do more of these, you develop technique and shortcut, and what you're seeing there is a shortcut that I normally take when I'm doing them myself and not trying to explain the process, and that's what occurred here. Knowing that 3 goes in there one time with 1 left over. So there's going to be a 2 whole on the outside and then a 2 1/2 on the inside. All right, I'm going to break it back up, by the way, as 2 to the 2 over 2 times 2 to the 1 over 2 times 3 to the 1 over 2 times x to the 6 over 2. Okay, now I have all my bases. And again, I'm showing every step and every explanation. You'll take your shortcuts once you understand the process. It's not that you're taking shortcuts, you are doing. You're just not writing everything down. And unfortunately, sometimes in math, kids think that not writing down math shows that you're a good math student. In fact, it's the opposite. What you would like to be as a really tremendous mathematician is to be able to articulate math with symbols. And that's what we're trying to do here. And that's what engineers do. If they're doing something, you'll be writing everything out. That's what you get paid for. Okay, so that'll be 2 to the 1 whole. And then I would also be able to have the 6 over 2. So that's x to the 3rd. Remember, we'll do an absolute value for that. And then underneath the radical will be 2 to the 1st times 3 to the 1st, bringing 2 back outside. Of course, that's 6, so that's 2. Well, I guess that could be negative, so we wouldn't need the absolute value there. Times the square root of 6. Now, what I mean by that, you saw me hesitate and stop there for a minute, bringing the absolute value, because you're allowed to have a negative, and your answer is allowed to be negative here. So I can leave that as it stands. Yay. All right, we'll try number 32 next. Oh, I forgot the sponge isn't wet, so... And I'm going to try to keep my videos down, somewhere in the area of 10 minutes or so. I can see on my clock I'm somewhere around 7. So I might do one more of this set and then go for, leave the rest for practice for an extra video. About 2 minutes, we'll see. Because they're all the same after this. In fact, let's jump up to 34. All right, we have the 4th root, 81, x to the 5th, y to the 4th. I have to watch how size I'm writing as my board is only so long, times the 4th root of 32, x to the 3rd, y. And you can see why I attach the files of the problems, as my writing isn't so clear all the time. So if you can't see the writing, please follow along with the text file I sent. Okay, what I'm looking to do is they both have the 4th root. So that's my denominator for all of the bases. So we'll combine our bases. When we do so, multiplying 81 by 32 would be futile. You're making more work for yourself. I need to break it into bases. So let's look at it that way. 81 is 9 times 9. Which is 3 times 3. So that happens to be 3 to the 2nd times 3 to the 2nd. 3 to the 4th. And then x to the 5th, y to the 4th, times, and the 32. So a couple ways you can break 32 up. It is at 8 times 4, which is 2 to the 3rd times 2 to the 2nd. Either way you go, you end up with 2 to the 5th when all is said and done. 16 times 2, the same thing. That's 2 to the 4th times 2 to the 1st. 2 to the 5th is 32. And then x to the 3rd, y. All of that is under the 4th root. Now you can appreciate why I wrote it like that, a problem that looks like it may take a tremendous amount of space. Well, now we're starting to reduce it down, and I'm not worried about so much board space anymore as I have the other half. Okay, I need to make sure that each individual base that 4 goes into it. So for the 3, that's good. For the x, I can put these together. So that's 3 to the 4th. I'll put the numbers in front. Now I'm going to deal with the 2. I'm going to break that up so that 4 goes into it. 4th and 1st. because when you multiply, you add exponents, so we're using that rule to our advantage, so at least we have 1 divisible by 4. Then we have the x's. That's x to the 8th, because we add exponents when we multiply. And then we have y to the 5th, which is y to the 4th, times y to the 1st. In fact, I'll leave it as it stands, because I already have a 4 divisible. 4th root. Now I'm going to write each base with its rational exponent, 4 over 4, 4 over 4, 1 over 4. I'm just copying the bases and putting the denominator for each of them. 8 over 4, 4 over 4, 1 over 4, and I end up with 3 times 2, 3 to the first, 2 to the first, x to the second, y to the first, and the ones that are left have the 1/4 power. They will remain under the radical. I guess I'll put the 2 first. Will I have an eraser on this? Which, of course, is 6x squared y, the 4th root of 2y. That wasn't too bad. It did send me over the 10-minute mark. Sorry. I hope it was helpful. Thanks.